Mysterious ambient music plays softly in background. We live in a universe of shadows and whispers. A cosmos that teases us with glimpses of its true nature, yet conceals its deepest secrets behind veils of darkness and light. I'm Dr. Morgan Richards, and today we venture into the most profound enigmas that haunt the minds of astronomers and physicists, the mysteries of the universe. What we know about our cosmos is merely a fragment of what remains hidden. For every question we answer, a dozen more emerge from the cosmic mist. Today, we'll explore these abyssal unknowns, these perplexing puzzles that lie at the frontier of human understanding. Consider this staggering reality. Everything we can see, everything we've ever detected with our most advanced instruments, all the stars, planets, galaxies, gas clouds, and radiation, accounts for a mere 5% of the universe. The remaining 95% exists as an invisible enigma, influencing the very fabric of our reality while evading our direct observation. The universe doesn't merely contain mysteries, it is a mystery. Its very existence poses questions that stretch the boundaries of science and philosophy alike. Let's begin our journey through these cosmic conundrums, starting with perhaps the most bewildering of all, the invisible forces that appear to govern our universe. The first great mystery, dark matter. In the 1930s, astronomer Fritz Zwicky observed something inexplicable. Galaxies were rotating too quickly. According to our understanding of gravity, these spinning collections of stars should have been tearing themselves apart, flinging their stellar members into the void. Yet they remained intact, held together by something unseen. This missing mass problem deepened when Vera Rubin confirmed in the 1970s that stars at the edges of galaxies orbit at nearly the same speed as those closer to the galactic center, defying the basic principles of orbital mechanics. The explanation? A halo of invisible matter surrounds galaxies, exerting gravitational influence without emitting or absorbing light. We call it dark matter, and it comprises approximately 27% of our universe. Despite decades of searching, we have yet to directly detect a single particle of this ghostly substance. Is it composed of exotic particles that barely interact with ordinary matter? Or does it signal a fundamental misunderstanding of gravitational laws? The answer remains tantalizingly beyond our grasp. Even more baffling is dark energy, a mysterious force accelerating the expansion of our universe. In 1998, astronomers expected to find that cosmic expansion was slowing due to gravity's pull. Instead, they discovered the opposite. The universe is expanding faster now than it was billions of years ago. This acceleration suggests an energy permeating empty space itself, a pressure pushing outward against gravity's attraction. Dark energy constitutes roughly 68% of the cosmic energy budget, making it the dominant force in our universe's evolution. Yet we understand almost nothing about its nature. Is it the energy of the vacuum itself, a fifth fundamental force, or evidence of extra dimensions exerting their influence on our 3D reality? Some theorists propose that dark energy might eventually increase in strength, tearing apart galaxies, stars, planets, and even atoms in a big rip. Others suggest it might be temporary, allowing gravity to eventually reclaim dominance. The fate of everything we know hangs in the balance of this enigmatic force. Black holes represent cosmic paradoxes incarnate, regions where matter collapses to infinite density, and the laws of physics as we understand them break down completely. At their boundaries, the event horizons, time and space exchange roles. Beyond this point, all paths lead inexorably toward the center, and escape becomes impossible, not because you lack sufficient speed, but because the very concept of outward ceases to exist. Yet black holes pose a profound challenge to our understanding of information and quantum mechanics. When matter falls into a black hole, quantum information appears to be destroyed, something forbidden by the fundamental laws of physics. This information paradox has perplexed physicists for decades. Stephen Hawking proposed that black holes slowly evaporate through quantum effects, emitting radiation and eventually disappearing completely. But this solution creates new puzzles. Where does the information about what fell in go? Is it encoded in the radiation somehow? Or does it point to an even deeper reality we have yet to comprehend? In 2019, humanity captured the first direct image of a black hole's shadow against the glowing gas surrounding it, the supermassive behemoth at the center of Galaxy M87. This triumph of science and technology, requiring a telescope the size of Earth through coordinated observations, confirmed many of our theoretical predictions. Yet it raised new questions about magnetic fields surrounding black holes and the mechanisms that create powerful jets extending thousands of light years. Perhaps most intriguingly, recent calculations suggest that black holes might be something else entirely. Ultradense collections of exotic matter just shy of complete collapse, or even doorways to other universes. These possibilities remain speculative, but remind us that even our most established cosmic understanding may be subject to revolution. Let us turn to the greatest mystery of all, the origin of everything. The Big Bang Theory successfully explains much about our universe's evolution, but the moment of creation itself remains shrouded in quantum uncertainty. What triggered the explosive birth of space and time? Was there something before? Can the concept of before even apply when time itself began at this moment? The earliest period we can reliably theorize about is cosmic inflation, a fraction of a second after the Big Bang when the universe expanded faster than light itself. This solves several cosmological problems but introduces new ones. What caused inflation to start? What made it stop? And why did it produce a universe with the particular properties we observe? The cosmic microwave background, ancient light from just 380,000 years after the Big Bang, gives us clues but incomplete answers. Strange anomalies in this radiation suggest our understanding of cosmic origins remains fundamentally incomplete. Equally mysterious is our universe's ultimate fate. Will the expansion continue forever, leading to a heat death, where entropy reaches its maximum and no useful energy remains? Will dark energy strengthen into a big rip? Might the universe reverse its expansion in a big crunch, possibly followed by another Big Bang in an eternal cycle? Some theoretical models suggest our universe might be just one bubble in a vast multiverse, an endless sea of universes, each with different physical laws and constants. Others propose cyclical models where expansion and contraction alternate eternally. Still others suggest that universe-sized brains in higher dimensions occasionally collide, creating new Big Bangs. Each possibility seems more extraordinary than the last, yet all stem from serious mathematical physics. We stand at the shore of a vast ocean of possibility, able to see only the nearest waves. Beyond these grand cosmic mysteries lie specific phenomena that continue to baffle astronomers. Fast radio bursts, millisecond-long pulses of radio energy from billions of light years away, appear and vanish without clear explanation. Some repeat, others don't, challenging our attempts to identify their source. Ultra-high energy cosmic rays strike Earth with energies millions of times greater than anything our most powerful particle accelerators can produce. What cosmic engines could possibly accelerate particles to such incredible speeds? The Great Attractor pulls our galaxy and thousands of others toward an unknown gravitational source. And enormous structures like the Fermi bubbles, massive lobes of energy extending above and below our galactic center, suggest violent events in our cosmic past that we're only beginning to understand. Perhaps the most haunting cosmic mystery concerns our apparent solitude. In a universe with billions of galaxies, each containing billions of stars, where are all the other civilizations? This Fermi paradox becomes more acute as we discover more potentially habitable planets. The silence of the cosmos is deafening. Are we truly alone, or is there something about intelligent life that makes it exceptionally rare or short-lived? Perhaps civilizations destroy themselves shortly after developing advanced technology. Maybe interstellar communication or travel is fundamentally impractical. Or could it be that we're simply not recognizing signals that surround us? The answers to these questions have profound implications for humanity's future and our place in the cosmic order. Equally perplexing is the apparent fine-tuning of our universe. The fundamental constants of nature, the strength of forces, the masses of particles, the balance between matter and energy, seem precisely calibrated to allow complexity and life to emerge. Adjust any of these values slightly, and stars couldn't form, chemistry would be impossible, or matter itself might be unstable. Is this extraordinary coincidence evidence of a multiverse where we naturally find ourselves in a life-permitting bubble? Or does it suggest something deeper about the nature of reality itself? The anthropic principle suggests we shouldn't be surprised to find ourselves in a universe compatible with our existence, but doesn't explain why such a universe exists at all. Some philosophers and physicists have even suggested we might live in a simulation, a universe created within a more fundamental reality. While speculative, this hypothesis remains consistent with everything we observe and might explain the mathematical elegance underlying physical laws. As we conclude our journey through these cosmic enigmas, we're left with a humbling realization. Despite all our scientific progress, we've barely begun to comprehend the universe we inhabit. The mysteries we've explored today aren't merely gaps in our knowledge. They're windows into fundamentally new physics, potentially revealing dimensions of reality we haven't yet imagined. Perhaps the greatest mystery is how a universe of mindless particles has organized itself into beings capable of contemplating their own origins. How stardust came to wonder about stars. In our quest to understand the cosmos, we ultimately seek to understand ourselves and our place within this vast, perplexing tapestry of existence. As you gaze at the night sky, remember that you're not just looking at distant lights, you're witnessing mysteries that have challenged the greatest minds in human history. And perhaps, in that moment of cosmic wonder, you'll feel what drives astronomers and physicists forward. The sense that the universe is not only stranger than we imagine, but stranger than we can imagine. Until next time, keep looking up and keep questioning. End credits roll with cosmic background music.